Hello everyone, welcome to my chemistry channel B.Ldash Short and Sweet in Chemistry. Now the topic is short revision of electrochemistry and here explanation of some terms in electrochemical cell. So what is electrochemical cell? What are the terms used here? We will see here. Now here point 1. External opposite potential. What is meant by external opposite potential? Actually, in electrochemical cell, chemical energy is converted to electrical energy. I hope you know, in electrochemical cell, chemical energy is converted to electrical energy, and that is equal to this electric energy as an electric potential that is equal to 1.1 voltage. Concentration of Zn plus 2 and Cu plus 2 ions, that is unity. Unity means 1 m. Here in electrochemical cell, what happened? The electrical potential that is 1.1 voltage and zinc and copper ion, that is concentration is 1 molar concentration. If external opposite potential is applied to galvanic cell where you are putting Zn plus 2 and Zn in Zn plus 2 solution, copper in copper plus 2 solution. And here galvanic cell slowly increases. If the external potential is slowly increases, then what happens? The reaction continues till the opposite potential equals the value of 1.1 voltage. Whenever 1.1 voltage is not coming, then it is only slowly increases and the reaction continues up to where it comes to 1.1 voltage. That is when this external potential less than 1.1 voltage, then what happened? Here anode is that is negative zinc, electron flows from zinc, and cathode copper, that is positive electrode, and here current flows from copper. That means anode electron flows and cathode current flows, and zinc dissolve at anode and copper deposits at cathode. Zinc, that means Zn plus 2 solution is there, that is there, and zinc electrode is there. Zinc in zinc electrode, the zinc dissolves, and copper, that is deposits at cathode. Number 3, when external field that is equal to 1.1 voltage. Before that I told less than 1.1 voltage. Now here we will see 1.1 if it is equal. Then reaction stops and no current flows. Remember, when the external potential is equal to 1.1 voltage, reaction stops and no flow of current is there. Then what happened? But further, if you want to further increase, now it stops. After that, you suppose you want to increase the reaction, that is in opposite direction. Third is, if it is more than 1.1 voltage, more than 1.1 voltage, then what happened here? Here, just opposite. Opposite means electron flows from copper to zinc, not zinc to copper. Current flows from zinc to copper, not copper to zinc. Copper dissolves at copper electrode. Zinc deposits at zinc electrode, just opposite when it is less than 1.1 voltage. And anode copper, the electron flows from copper to zinc. Cathode, that is zinc positive, and current flows from zinc to copper. You can observe it is just opposite when it is less than 1.1 voltage. Electrode potential. Then now we will come to point electrode potential. What is mean? When an electrode is immersed in a solution of its ion. When an electrode is immersed in a solution of its ion means, suppose zinc is in solution zinc sulfate. Copper in copper sulfate solution. The tendency of a metal ion from the solution to deposit on the metal electrode to make it positive charge. What is the tendency? Tendency that is from metal ions to deposit to metal electrode and to make it positive charge. On the same time, metal atoms of the electrode to go to solution. Similarly, metal atoms that mean of electron go to solution as ions and leave behind the electrons at the electron try to make negative charge. That means here metal atoms electron go to solution as ions and making as negative charge and equilibrium established between two. One is losing electron, other is gaining electron. That is why how it lose electron and how it make a equilibrium between them. Just like example, copper is an electron and when it loses electron, it gives Cu plus 2 solution and 2 electron minus. Suppose zinc also, if you say zinc also lose electron and here copper plus 2 here reversible sign you should put here. It is not a reversible sign. Actually copper loses electron in equilibrium position is there. That is why it is called. So you see here this is the equilibrium sign. And due to separation of charges between electrode and its solution. Now see, Cu as electrode and Cu plus 2 as solution, a potential difference developed. A potential difference developed between electrode and electrolyte. That is called electrode potential. I hope it is clear to you. That means when copper loses electron and changes to Cu plus 2 in solution, not free solution, then what happens? A potential developed takes place between this electrode and a salt solution, and this is called electrode potential. And when the concentration is 1m, when the concentration of the species in half cell, either copper or zinc, in half cell, if it is unity 1m, 1 molarity, then it is called standard electrode potential. There are two types of electrode potential. One is oxidation potential, other is reduction potential. What do you mean by oxidation potential? The word itself indicates what is here oxidation potential. Gives the tendency of electrode to lose electron. You know oxidation means lose electron, then oxidation potential means when losing electron, and that is an electrode. An electrode when lose electron, that example zinc, this gives Zn plus 2 aqua, and here you can write solid also. Here you can write solid and in solution, so it is Zn plus 2 and losing electron 2 electron. Reduction potential gives the tendency of an electron to gain electron. Reduction potential means when gain electron. That is called reduction potential. You can take example also. Cu here, Cu plus 2 plus 2 electron, it changes to copper. It is aqueous and it is solid. Oxidation potential is the reverse of reduction potential. Oxidation potential of the same electrode, not different electrode. Oxidation potential of the same electrode is reverse of reduction potential. Oxidation potential of zinc is plus 0.76 and reduction potential what? Just opposite mean, just reverse mean minus 0.76. Again remember, oxidation potential mean when lose electron it gives oxidation potential. When gain electron it gives reduction potential. Oxidation potential of the same electrode is the reverse of its reduction potential. Suppose you want to see zinc. Oxidation potential of zinc 0.76, reduction potential of zinc minus 0.76. 0.76. According to present convention, now oxidation, reduction, two words are used before, but nowadays only one word used for one electrode. One electron, just like C, reduction potential, that is electrode potential. Nowadays what is saying? Reduction potential means electrode potential. There is no word use oxidation potential. So remember the sign, negative, positive, what sign is used, that is for reduction potential. According to IUP convention, now IUP also changed the convention. Here, standard reduction potential means standard electrode potential. Reduction means main, that is electrode potential. There is no word use oxidation potential. So, in a galvanic cell, the half cell in which oxidation takes place, that is called anode, it has negative potential. Anode means negative potential with respect to solution. Similarly, the other half cell where reduction takes place, and that is called cathode, that is positive potential with respect to solution. Remember, galvanic cell not only used for zinc and copper, it can also be used any metal as required, as possible, as the galvanic cell can be prepared. So the other half cell in which reduction, remember, where oxidation takes place, that is anode, negative potential. In a galvanic cell, the half cell here where oxidation takes place, that is anode, and it has negative potential with respect to the solution. Similarly, the other half cell of galvanic cell in which reduction takes place, that is called cathode, that is positive potential with respect to that is solution. That means here in galvanic cell you can say one is anode, other is cathode. In anode, that is a negative potential where negative potential where oxidation takes place. In cathode, where positive potential with respect to solution where it is cathode. So after that, a potential difference exists between two electrodes. When the two electrodes are there, that is your cathode and anode, then this difference, the difference of two cathode and anode potential, that is called potential difference exists between. Here it is cathode and anode. So when the switch is on, when you make a cathode and anode, when switch you will make on, what happen? The electrons flows from minus negative, that is negative electrode, to positive electrode, and just opposite current will flow from opposite side. Then here that current, that electron flows from negative to positive, and current will flow from positive to negative. Then what is cell potential? Then come to point cell potential. The potential difference between two electrodes of galvanic cell is measured in volts. Then what is cell potential? The potential difference, how we will calculate between two electrodes, and that is cell potential, and it is measured in volts. Cell potential equal to electrode potential of cathode minus electrode potential of anode. And both are regarded as a reduction potential, no word oxidation potential, and that is in volt. So cell potential also called electromotive force. Remember, electromotive force, that is also called cell potential. Reduction occurs, that means acceptance of electron at cathode. Oxidation occurs means loss of electron at anode. Remember, reduction means, that is here acceptance of electron takes place, and where oxidation occurs means loss of electron takes place at anode. So anode is at left side and cathode is the right side. So what is EMF here? EMF means directly you can say reduction potential of cathode minus reduction potential of anode, or E cell equal to E cathode minus E anode, or you can say E right minus E left. E right means what? E right mean here the cathode. Right mean cathode. And E left mean anode. So cathode minus anode. Remember carefully, cathode minus anode. EM of a cell as the potential difference between two electrodes. What is EM of cell? That is potential difference between two electrodes of the cell. A cell consists of two half cells. When no current is allowed to flow in the circuit, when the current not allowed to flow in the circuit, at that time EM of the cell equal to potential difference. So what is cell reaction? Zns Cu plus 2, that is gives Zn plus 2 aqua plus Cu. That means Zns loses electron, changes to Zn plus 2 in aqueous solution. Similarly, Cu plus 2 in aqueous solution gain electron and changes to Cu solid. So here half cell reaction, how can we say half cell reaction? One is cathode reaction, another anode. Cathode reduction takes place, anode oxidation takes place. So here what happened? Cu cathode, what happened here, that aqueous solution, in aqueous solution here Cu plus 2 accept 2 electron, it changes to Cus. Similarly, anode oxidation takes place, zinc solid, what happens, zinc solid here loses 2 electron, it changes to not Zns, sorry, it is Zn plus 2. So I have to check it and clarify, rectify it, that is rectify that one. Yes, it is aqua. I can write here aqua. There is here. So after losing electron, it changes to Zn plus 2 aqua in solution. In solution stage here plus 2. So you can see here that how can you Zn as Zn plus 2 double sign, here vertical line 2, here Cu plus 2 aqua and Cu solid. Again see Zn as one vertical line, Zn plus 2 aqua, double vertical line Cu plus 2 and that is vertical line Cus. What is double sign? Double line means salt bridge. And one single line means Zn in Zn plus 2 electrolyte. Cu plus 2, Cu in Cu plus 2 electrolyte. So here E cell equal to E right minus E left, that is E right means copper. Copper plus 2. Copper, here we should write copper plus 2. And here Z minus Zn plus 2 Zn. So example to cell reaction, suppose copper and copper in copper sulfate solution, silver in silver solution, silver salt solution. Here you can, how can you write Cus, that is changes to Cu plus 2 aqua. Ag plus aqua changes to Ag. So 2Ag plus aqua gives 2Ag. So half cell reaction cathode, how to write? 2Ag plus accept 2 electrons, it changes to 2Ags. That means after accepting, this is 2Ags. And here anode oxidation Cus, Cu plus 2 aqua plus 2 electron, and the cell is represented as, so cathode oxidation cathode reduction takes place, anode oxidation takes place. The cell is represented as Cu as one vertical line Cu plus 2 aqua, double vertical line Ag plus aqua and oblique Ag. So E cell equal to E right minus E left. E cathode minus E anode. Here silver, that is as a anode as cathode, and copper as anode. So here E cell equal to E right minus E left. E right means E cathode minus E anode. So here E Ag plus Ag minus E Cu plus 2 Cu. That means here E cathode minus E anode. I hope it is clear to you, and in next topic I will clarify all the points. Myself Vijayalakshmi Das, EXPGT Chemistry, Kendra Vidyalaya Sangathan, and thanks for watching my video. Again, thanks.